different from most people you'll hear at this event because I actually literally wrote the book on why AI projects fail. And I had done about 1,000 projects at that time, and I found that there was a systematic pattern to why AI projects fail. And does anybody want to guess what's the success rate for AI projects? Who wants to guess the number? It's actually 10%, so you were meaner than, but like 10% is pretty bad, right? If you think about, and the funniest thing is that number has not changed. Like that number keeps coming up, even with GenAI projects, it's at 10%. And one of our focus has been on getting customers to value. I'll skip past this is the marketing stuff. But what we were focused on is if GenAI projects, if only 10% of these things are going to succeed, you have a really bad situation right now where Gartner's saying these projects take 8 months to do and cost about 2 mil to 16 mil. Who wants to put their career on the line for this? How many of you are doing GenAI projects? So you are now in that category right now, according to Gartner. And what we were obsessively focused on was, usually it was the disconnect between business and data science that causes AI projects to fail. But most of the time in these organizations, it is IT and data science that are starting the projects, building apps, building prototypes, hoping that business will someday take a look at it. After they spend 9 months, that's when business often gets their hands on it for the first time. Does that make sense? Right? So we flipped the equation and we said, look, we need to be able to get prototypes in the hands of people in 2 days. And we need to be able to iterate and improve it until things get solved in 30 days. Now, there are exceptions to it, like Carelon, which is the Fortune 50 Anthem. They got their project done in 2 days in their data. Verizon got it done in 7 days, but they decided to do model fine-tuning, which is complicated. But the point here is that we don't have to accept this mindset of these projects are going to take 8 months to do, and we don't have to accept the mindset that the risk is on us. If the technology really works, if AI is as good as we claim it is, it should be extremely easy to deliver value. Then why can't we? So one of the things that happens is, how do we evaluate a generative AI model? Any data scientists in the room? Or anybody who wants to admit? Okay, well, there's one from my team. Anybody else? Okay, well, okay, you keep me honest, because I wouldn't quite call you a data scientist because he really is an expert. But if I'm evaluating an AI and I'm going to test it, what I typically would do is I would have a question and a golden answer. Okay? So the question is, which country has the largest GDP? You can see the golden answer. This seems reasonable, correct? So let's say I give you 3 Gen AIs, which give you these 3 answers. Take a moment to read them. How many people are going to vote for Gen AI 1 as your preferred choice? Gen AI 1? Nobody's voting for Gen AI 1? Okay. Okay, 2 people voted for Gen AI 1. How many people want to vote for Gen AI 2? You guys are not going to vote on anything, then the project doesn't work, okay? Okay, I will just make it easy for you guys. The correct answer is Gen AI 1, okay? But here's the problem. If you look at the top data science metrics being used today, the 2 wrong answers would do better than the correct answer. Why is it? Because generative AI models are being evaluated on how well they overlap with the answer that was given in the golden answer, right? It's how many words you overlap. In the case of Rouge, it is literally how many words you overlap at a high level. For Meteor, it's a little smarter. It's like, word order matters, synonyms matter. But the point is, you're just trying to say how similar are the answers instead of are the answers correct. But then you have to think about other things. Business users might have preferences for brevity. They want it in bullet points. They care about the brand guidelines. There are many, many subjective things. This is the fundamental problem with every single generative AI project today. Does this make sense for you guys? Like, once you have made this mistake, the rest of it doesn't matter. Because you're playing Russian roulette. What you're basically doing is, I'm going to use data science metrics and build something and hope that somebody will use it. Okay? Now, this problem, you have to go into this approach where you have to let business users prototype GenAI solutions. You have to flip the equation. Look, data scientists are extremely important because your business users have no idea what prompt engineering is. They have no idea how to do a vector DB setting. They have no idea how model metrics should work. I'm not saying you don't need data science. I'm saying reverse the order. The order has to be a business user has a question. I want to figure something out. I should be able to point it at structured data, unstructured data, semi-structured data. I shouldn't even need to know what any of those things mean. And I should be able to use generative AI to extract value from it. So 4 years running, we have run this contest at UC Berkeley, where we took a bunch of high school kids, history majors and MBAs, and gave them 90 minutes of training and put them up against expert data scientists using their favorite tools. This was at UC Berkeley, right? So the data scientists are pretty smart, by the way. These are not dumb data scientists. Anybody wants to guess how many times the data scientists beat the high school kids out of the 4 years? Never. All 4 years, the high school kids beat the expert data scientists. That should really get you to start thinking. But if you reverse the equation, you use the business user first to make sure that what you have built is actually what they're looking for, what creates value for them, then data scientists can iterate and improve. And there, like in the first part, all we are doing is, can the user prototype? And if you come to the session we are doing in the room over there right after this, we'll be showing this live. Like we'll take a random data set. In fact, some of you have actually provided data sets to us today, and we basically did these prototypes today. But the point here is you should be able to take a data set and do a prototype in a matter of minutes. The second part of this is you need to try different combinations. You need to prototype, you need to experiment. But these need to be done in a very, very rapid iteration manner. So how do I take an application and put it in the hands of many, many users all at the same time and have them just start giving thumbs up, thumbs down? I have to be able to change all of the configurations, model configurations, database configurations, vector DB configurations, how much money I want to spend, what my prompt should be. All of that should be configurable, but you should be able to test it massively in parallel all at the same time. We call this AZ testing. And this is the second half of the equation. The first part was get that prototype done in 2 days. The second part is iterate. We sometimes will do 4 iterations in a one call with the client, right? So when you can iterate many, many times, this 30-day guarantee has been a very easy thing for us to hit. We typically hit it in like 2 to 5 days, we'll get the thing done. But we have a 30-day guarantee. Have to change the way you're doing generative AI. The next problem is, how many of you only have unstructured data in your company? Generative AI is obsessed with unstructured data because that's what it was designed for. I have a vector database. What happens when I'm in the world of structured data? I'm back to natural language querying, which has existed for 20 years, right? I'm still required to ask the right question of my data. If I could ask the right question of my data, I could have done a drag and drop and got the chart. Why do I need generative for that? So you need to start thinking about how you can have an equivalent of the vector DB for structured data. And by the way, you need semi-structured too, and we'll talk about that in the session that we are doing next. Like imagine you're looking at customer reviews. All of us have done structured analysis of customer reviews, and we have done sentiment analysis of customer reviews. But what about the two things together? I should be able to actually looking at, what's happening when I'm getting a low rating, my competitor is getting a high rating. What are the thematic elements of that? That's a semi-structured question. Does that make sense? Now, what we did in Aible is we said, look, vector databases, when you ask a question, they go in and figure out what snippets are relevant to your query, and they send that to the LLM to summarize. Well, for structured data, when a question comes in, let's say, how can I sell more to young people? I need to go find the charts that are relevant to that question and send that over to the generative AI to summarize. It's not that different. But you have to think about structured as well, because 80% of our data by volume is unstructured, but 80% of our data by value is actually structured. You cannot ignore structured data. Any questions, comments on this? This makes sense to people, right? Now, let's say there is a business question. How many of you are analysts in this room? Like you consider yourself analysts? Okay. I might have to go to you to keep me honest again, okay? Because he's an expert on a bunch of these things. So if I have a question like how do I sell to young people and I want a business answer, there are actually 4 steps in the middle. The first, I have to find and clean the data. Then I have to come up with the analytics question, because you can't ask a question like, how can I sell to young people of your data? That's not a natural language query question. Does that make sense? That question cannot generate a chart. It's not an analytical question. Then I have to answer the analytical question, and then I have to summarize that into a response for the end consumer. That's what the analytical process is. And the problem has been till now, that first step is completely manual. The second step is basically what the analysts do. They sit down and they come up with questions, and they'll come up with 10, 20, 30 questions. Once they get 4 or 5 good-looking charts, they stop. That's the standard analytical process. Get enough charts that your boss won't shout at you, and then you stop, because it's very boring to come up with new questions to ask of your data. Third is, how do I get these questions answered? Well, basically use Tableau, Power BI, things like that for it. Now, one of the interesting things we ran into is because we were looking at millions of questions automatically, there was a big concern from people, oh my God, this would be very expensive. Right? I'm asking millions of questions. Here's the funny thing. If you look at how Snowflake or Databricks or BigQuery, any of these guys work, they charge you based on the length of time they're running to answer your questions. Now, an AI can ask 1 million questions in the time a human can ask about 5 questions. Does that make sense? So you're just cramming 1 million questions in the cost of 5 questions. But not all of those 1 million questions are useful. If 1,000 of them are useful, you get a massive leverage though. All 1 million questions don't have to be useful. And we have customers like United Health Group and others that have talked about 1,000x lower cost. We did a blog post with Google showing 1,000x lower cost of analytics by using this technique. For the previous speaker who was talking about energy consumption, it's the same idea. You're just using the compute resources very, very efficiently. Today, if you think of a car, the biggest problem is these computers are like your personal cars. You're using it once or twice a day, otherwise it's sitting around. What serverless does is you are just using it like an Uber. You're constantly using the car. You're sharing the car between different people, so you get more utilization out of each car. And by cramming many questions in very quickly, you're leveraging the way computers are actually set up to do. AI is perfect for working with computers because computers have always been faster than humans. Now you can actually have something that's as fast as the computer. Why are you asking questions one by one? Last part of it is using generative to combine all the pieces together. That's the story. And if you come to the talk right after this, you'll see this being done live. But to the question I was talking about earlier is, how expensive is this? Well, Sienna, 700 data sets, 150 million questions, $50 of cloud compute cost. That's the key point here, is that this doesn't have to be hard. You actually can get far deeper rigor through using AI. But the key shift you have to do is it has to be AI first. If you are having the human do a lot of work before the AI can come into play, it won't work. And it cannot be AI only. It's AI first, not AI only. You still need the human to overlay human intuition and domain knowledge. So I ran one of the largest healthcare analysis ever done at that time with McKinsey, where we looked at 30 million patients across 1 million variable combinations. The thing that the AI was most excited by was a diagnosis that only happened for one gender, for a specific age group, and they almost never relapsed in faster than 9 months. Can anybody guess what this disease was? Childbirth, right? To an AI, that is an incredibly insightful pattern. And it would not move off that pattern. We couldn't get it to move off that pattern. So as a human, you have to say, okay, got it. Let me take all the pregnancy-related data out of this. And then it started giving us really interesting patterns like diabetes for young women, which was a pattern that was not known at the time. We were the first people who found that young women were not taking insulin as a dieting strategy. And they were getting rehospitalized as a result, right? So once you help that AI, think of it. Anybody remembers the early days of the Roomba where it would get stuck and you would kick it to make it go that way, right? You gotta be ready to kick the AI. It's AI first, not AI only. But if you go human first, you're already stuck. You've just given up all the value of AI already. Does this make sense? So, other part of this, and this is crucial by the way, you cannot use AI without the right guardrails. Now, I have had people come in and tell me, Arijit, could you help us create a training program for proper usage of AI? And I'm like, no. I can't. Because your users are not going to listen to you. You cannot solve this problem through training. Because if AI is going to be completely pervasive, imagine a world where you train people on using a browser. Would the internet have been that pervasive? Right? If AI is that pervasive, it cannot be a training-oriented solution. What you have to do is you have to structure things by design. You have to make sure your data is always inside the cloud, inside your control. It can never leave your control. Your models need to run inside your control. Your vector DB needs to run inside your control. You need to have automated systems double-checking for hallucination. But not ask a generative AI, hey, did you hallucinate? Where did you get this data from? That makes no sense. It'll make up the source. Right? You can't have a deterministic system double-check it. You can't leak information. So, very silly idea, but until about 3-4 years back, we did not know that neural nets can memorize social security numbers. And we have been using neural nets for at least 40 years now. Okay? GenAI, if I'm doing fine-tuning, can definitely memorize information. And there is no way to prove that they don't memorize information. So you got to think differently. You got to have your model, the model weights, the vector DB, all of these be user and use case specific, or at least role specific. You got to think differently about these technologies. But these have to be bottoms-up solutions. It cannot be that the user has to do the right thing. It has to be that the user can't do the wrong thing. Does this conceptually make sense? And one of the benefits of using the serverless technique is we run it on all 3 clouds. We optimized with Intel, we optimized with NVIDIA, we work very closely with these companies. But the result of it is everything is running inside their cloud under their control, which has a data security benefit, but it also makes people comfortable with doing that rapid prototyping. If there was a risk that the data that the user was doing rapid prototyping on would end up in your competitor's hands, you'd be very, very worried. But if you know that the whole platform is secured and controlled and the user cannot take the data out, now you get a lot more comfortable. Does that make sense? You have to build these walled gardens. You can't do it through training. The other part of this, the clicker has stopped working. Maybe if you could progress to the next slide for me, and you can build it out. Excuse me, sir. Excuse me, sir. The clicker has stopped working. Could you tell him, please? The clicker has stopped working, so if you could please go to the next slide and build it out fully. Thank you. If you could just build it out fully. Thank you. Like 4 clicks. So what we do is we have the generative AI create a summary based on the user's question. But then we actually have a second system double check the output of the generative AI. So we are parsing through everything and saying, can I find the source document that this information came from? And if I can, I highlight it. And if a user puts their mouse on top of it, I can see the charts. Does this make sense? And when you're using a deterministic system to double check, you can log the Python code in the customer's environment. We do a lot of work with highly regulated companies. And one of the things they run into is like, for example, how do I go to the government and say, hey, I used this information and this information was correct? Well, if I have a second system double checking and there is Python code in my environment, I can confirm that the information the user looked at was correct. Does this conceptually make sense? And one of the funniest things you'll find in hallucinations is hallucinations will happen at random points in the middle of the document. It won't be at the beginning or at the end. It's very hard for a user to go find them. Next slide, please, if you don't mind. So the approach we took, by the way, because the success rates have been so low, what we went in and said, well, why don't you guys choose a use case and we'll just go build it. We'll build it in your cloud, build the whole use case, give you access to all users for that use case for a year for a set price. So we went to a very different mindset with Aible, where instead of just selling licenses, we just said, you know what, let's make people successful. Let them do 1 project, 2 projects, and then they start saying, well, you're doing these projects so fast, I want the licenses, I want to do it myself. But you got to get them to successes first. Once business users get success, then they're willing to try many other things. Hopefully that makes sense. You can come to the booth 321, or if you come next door, you can ask, you can see the demos of what we're doing. But any questions for me? I know we have time for maybe 1 question.